Good evening, everyone. So we are going to start the meeting for the day. The Research Learning Circle is bringing this is the sixth lecture series, and today we have a speaker, uh, Ms. Sila Mishra from IIT Kanpur. I would like to invite Tiasa Mishra to um, introduce the guest. Tiasa Mishra.
Seela Mishra is a research scholar in the Department of Economic Sciences at IIT Kanpur. Her area of interest primarily lies in applied microeconomics and the economics of family and gender. As part of her research work, she has explored the efficiency of the Indian banking sector, network readiness of countries, and technical efficiency of the Indian judiciary. She is currently exploring India's time use survey. Over to Seela Mishra, please.
Thank you, Tiarsa, and thank you, Jawahar. So, I'll be presenting. Hope my screen is visible.
Yes, it is visible, and
Fair enough.
the session is all in your hand.
Okay,
All is yours. You have to handle everything now.
okay, okay.
Thank you.
So,
Yeah,
following the previous discussion on data and development analysis, which is a parametric approach of a production function, and therein we estimated technical efficiency, right? So, in this session, we're basically discussing the theory and the application of stochastic front-end analysis. Now, as I mentioned, that the purpose of this discussion would be to use a parametric technique wherein we would have a production efficiency. I would like to reiterate that in the parametric approach, we assume a production function, whereas in a non-parametric approach, we do not have any such assumption of any such assumption on production function. So, data and development analysis was based on a non-parametric approach, and the approach that we would be discussing in this discussion is a parametric approach, also known as stochastic front-end analysis. So, for the students who are who have an economics who have the background of economics, might be aware of the term stochastic, which is a kind of random component that we also have in our regression analysis in a regression framework. So, I can't say that any method is superior to any other method. However, in when we talk about technical efficiency, then we have some methods, and based on the limitations and the advantages of some methods, we rely and also the literature review, we primarily follow a particular method. So uh, so now, in this discussion, we for example, so we let's take an example of a bank where the main objective of a bank is to disburse loan, and for that it uses some inputs like the employers, the rent that it pays, and the expenditure that it incurs every year, and also the amount of deposit that is it has. Now, in that case, it might so be the case that the bank could be efficient, but it can also happen that the banks might become inefficient. That is, the amount of input that they are using to produce output, such as the disbursement of loan, might not lead to efficiency. So there might be some gaps, like there would be management practices that need further attention from the bank side, or even the technology gap that the banks might be suffering, or even some external factors. So, stochastic front end analysis helps us quantify and analyze these inefficiencies. And just like in data development analysis, wherein using a linear programming problem, we obtained some technical efficiency scores. In stochastic front-end analysis, we would have a different approach. However, the technical efficient. However, in this method also, we would be leading to technical efficiency scores. So, moving forward to who gave stochastic front-end analysis and how did it develop. So it was primarily introduced by Einel Lovell and Schmidt, and Musen Van Den Broek. So these two papers developed at the same time, but in different countries. So, but they came up with one proposal on stochastic front analysis, and it has become popular subfield in economics. So there are various journals that have published lot many articles on DE and SFA, and based on their merits. So where can you apply stochastic front analysis? So as I mentioned in the previous discussion also, that the data number analysis can be utilized in n number of cases. Like it can help us in estimating the efficiency of banks, judiciary, energy sector, and even the public utilities like education and healthcare sector. So in the same fashion, stochastic front analysis can also be applied in these cases like agriculture, manufacturing, healthcare, and services. So it is why it is crucial for anyone to know what the efficiency is, because that might help in their policy formulation, even to understand whether the resources that they are utilizing to produce the output is leading to efficiency or not, which is the basic goal in production framework. Now, herein I'm discussing stochastic front analysis, the mathematical model, the interpretation of results, along with the application in the real world. And moreover, I will also be discussing advantages and limitation of stochastic front analysis, and would conclude with key takeaways. Now, you might be aware that you might be aware of the production function that is there in the green box, right? So a firm produces some output which is nothing but qi, and it uses some amount of input which are zi, and betas are the associated level of coefficients, right? So but there might be a case that these firms might be inefficient. Okay, so in that case we would be introducing another error component, which would be an inefficiency component called xi. So xi is the level of inefficiency of xi basically shows the level of efficiency of firm I. So if it is equals to 1, then it's well and good that the firm is efficient. However, if it falls below 1, then it would be called inefficient. So now, if moreover, so the model framework in stochastic production frontier function combines both deterministic and stochastic components. So what I mean by this is that, so in a regression framework, we have a dependent variable, we have a host of independent variables, and we have an error component. So but error component is also the random noise component. But in stochastic front-end analysis, along with the case of dependent variable and the independent variable, we would have two kinds of error in the model. One is the inefficiency capturing error term, and the other would be the random noise component, which is also there in the regression framework. So it's very important to distinguish between how stochastic frontier analysis work as compared to regression framework. The difference primarily lies in the way the error term is captured. So in SFA, error term is composed of two kinds of error. One is the inefficiency capturing error term, and the other one is a random noise. Whereas in a regression framework, we just have this random noise component. So one might ask, how is this random noise different from inefficiency? So random noise is different from inefficiency term. So basically, the inefficiency component can be controlled by a firm. However, the data on the same may or may not be with the firm. So for example, in the case of a bank, it is very difficult to get the data on managerial skills or even the technology gap, right? So these factors would be subsumed in the inefficiency error wala component, whereas random error component could be a number of factors like political instability, or even the economic instability that happens in across the world. So I hope that now you are clear with the difference between inefficiency error component and the random error component. Now, now with this, we move ahead to the model framework of stochastic front-end analysis. So as I mentioned, just like a regression framework wherein we have a dependent variable, independent variable, and random noise component, we would have the same function. Plus, we would also have the inefficiency component captured in the model. Where now, for the sake of clarity, why is the dependent variable, which is the observed output by the ith firm. So in the case of bank, this would be the amount of loans disbursed by the bank. Fxi beta is the deterministic production frontier with the parameter beta. You might be aware of this function f of xi beta, where xi is the amount of inputs and beta the associated level of parameters. Now ui in the model is the inefficiency component, which would take care of the managerial skills, the technology gap. We might not have the data on these variables, but we do capture inefficiency component in SFA. Now VI is a random error component, which is nothing but the account, but which is nothing but it accounts for noise and the unobserved factor with again mean zero and variance constant. Now, so how does that function? Now, so there are so as I mentioned that in a regression framework we do assume a distribution for error component, right? In the same fashion we would also be assuming some functions for random error component, and based on them the results would also change. So for example the base so frontier model also provides estimators for the parameter for three basic kinds of model, right? One is where the error term assumes exponential distribution, the other is a half normal distribution, and the third one is a truncated normal distribution. Now how is half normal distribution different from normal distribution is that normal distribution basically has a real line as its base, whereas in half normal distribution it will be cut to the positive side only. So in half normal distribution it is the distribution is skewed toward the distribution is only the right part of the normal distribution. Moreover, when it comes to truncated normal distribution, there we assume that the limit would be in a particular interval, which is why which is why we have a lower interval, lower which is we have a base and the ceiling, and that's how we assume truncated normal distribution. Now, what are the estimation methods? So uh, in the regression framework we use OLS, we use MLE. In the similar fashion, in stochastic frontier analysis, this method uses two kinds of approaches. One is the maximum likelihood approach, and the other one is the Bayesian method. Now, maximum likelihood estimation is a common method which is used to estimate the parameter of the SFA model. So, in most of the papers that you would come across in journals would be using maximum likelihood estimation. But for the efficient results and the kind of iteration that it requires, people do also use Bayesian for robustness checks. Now, so in MLE, the estimation technique finds parameter values that maximize the likelihood function given the observed data, and the aim is to make the observed data most probable under the assumed model. So we want to reach the assumed model, which is why we would be maximizing the likelihood function. Moreover, in the Bayesian method, there are certain um Bayesian method basically incorporate prior information about the parameters, and then it updates the observed data to obtain a posterior distribution. Now, so uh, moreover, what are the assumption and the challenges in performance stochastic front analysis? So the first one is that both MLE and Bayesian method require assumptions about the distribution and inefficiency in error term. And in SFA, we do need to make certain assumptions about the kind of distribution of the error component. So a priori you need to tell the system whether you are assuming normal distribution, a half normal distribution, or truncated normal distribution, or even the exponential distribution of the inefficiency error term. So that might be challenging, and for that you need to either validate through literature or through standard text. Now, the estimation in SFA could be challenging, especially with the complex models or even limited data. So one needs to know one needs to also make sure of the degrees of freedom that we do need in regression analysis also. So I'll show you the challenges that are faced when you have limited data or the limited data points. So, how is data and number analysis different from stochastic front-end analysis? So, in the previous discussion, I had mentioned that in DA one assumes CRS or VRS, but one can assume CRS or VRS, and either based on the literature or based on the flexibility assumption that one might be ready to accommodate. However, in stochastic front-end analysis, as you might have seen. That there is no such assumption of CRS and VRS in SFA. However, we do require distributional assumption of inefficiency, like Do you want your inefficiency term to be following exponential distribution, or half normal, or truncated normal distribution? Moreover, in DA does take care of multiple outputs and multiple inputs, but in stochastic front-end analysis, you need to have only one output to produce a number of. You need to have one output, and it could be more than one input in your case. So. Mm, the other thing is that DA lacks the flexibility in handling stochastic noise or random error component, which is what I also mentioned in the first slides and so forth. Also, that in DA, that we do not make any assumption on the production function. We neither make any assumption on production function, nor we make any assumption on the noise component. Therein we didn't talk about the noise component. However, when it comes to stochastic front analysis, we need to assume a functional form of the production frontier, and which and the results would be sensitive based on the assumption that we are making in SFA. Now, in data and number analysis, one thing that one needs to take care of is the extreme data points, like the case of outliers. You cannot compare apple with the oranges, or if you're comparing fruits, then you need to take if you're comparing the production units, then you need to make sure that there are no outliers in the data. So if you're comparing all the banks in India, and not comparing just the branches of one bank, then you need to take the caution of the fact that the results would be sensitive to the data points or the outliers in the data. In the stochastic front analysis, it requires a specific kind of data, and it can also handle panel data as well. And in data number analysis, one cannot identify what are the sources of inefficiency. However, in stochastic front analysis, you can identify what are the sources of inefficiency in the model. So uh, in the previous discussion, I mentioned that after estimating the technical efficiency scores, you can regress them over host of independent variables and host of other variables that might be impacting efficiency score. But that's a different approach, right? But in SFA, one need not perform separate regression, and the SFA takes care of the inefficiency model. So you would first you have a model wherein you have independent input variable and the output variable. Based on the efficiency scores derived from the SFA model, the model would itself regress it over the inefficiency causing variable that you might have inputted in the equation. Now, so I hope the difference between DE and SFA is clear. That DE is based on parametric approach, and SFA is based on DE is based on non-parametric approach, and SFA is based on parametric approach. In DE, one needs to take care of the assumptions of CRS, VRS, and even one needs to take care of the outlier. Whereas in SFA, one needs to be particular about the kind of assumption of on distribution for efficiency. Now, we'll be further delving into the cross section of the panel setup. So, just like DA, SFA can also be applied in a panel setup and in cross sectional setup. And moreover, so how can we interpret the results of stochastic front analysis? So just like in data number analysis, where the technical efficiency scores lies between 0 and 1, the close interval of 0 and 1. In the same fashion, the technical efficiency scores derived from stochastic front analysis would also be in the close interval of 0 and 1. So if your technical efficiency is equals to 1, then that means that the particular decision making unit is technically efficient. However, if the technical efficiency score lies below 1, then you might conclude that the decision making unit is inefficient. Now, based on the technical efficiency score, you would also be commenting upon the implications of high and low efficiency score. So I'll be again following the previous data on 24 high courts of India. So you might have observed that the number of decision making units in the current case is just 24. And I would further comment upon the number of observation and what it might lead to in stochastic front-end analysis. So in our case, there are 24 high codes for which we are estimating the technical efficiency score. Now the inputs the outputs in our the output in our case is the cases disposed of by each and every court in India. The input by the input of the inputs are the caseloads or the number of pending cases with each court, the judges, the judicial staff, the expenditure allocated. And in DA, we had assumed output oriented model, and the returns to skill assumption that we had opted for in our previous case was VRS or BCC. But for the current case, that is in this SFA, we just need data on these on the highlighted things only. Now, so this is the data wherein we have these many high courts followed by the data on cases disposed of, cases pending, judges, judicial staff, and budget. Now, to perform stochastic front analysis in Stata 14, you need to first load the data set, and then you would estimate the stochastic front end model using the following code, wherein wherein after frontier you would be putting the variable name of output followed by the inputs. Now, in our case, since the output variable was the cases disposed of, we have just named it as ln, which we have just named it as output, followed by the inputs. One need to make sure that the variables are taken are in the log form, and beforehand. So before delving into performing the analysis in Stata 14, one needs to have all the variables converted into log form, and then we would predict the technical efficiency score. So now I'll show you the the state in Stata 14. I'm just inputting the command for SFA, where frontier is again the command for SFA, followed by the level of followed by the log of output and the log of input. So so here are the results of frontier frontier, and I've also taken the screenshot and just pasted it in the file. Now, so we see that um, here we see that the log of pending cases has a log of pending cases. Judges and judicial staff has a positive association with the log of output, whereas the budget has a negative effect. When we look at the but when we look at the statistical significance of this thing, we do find just that the pending cases has a positive association with the output variable, and also the staff. So with increase with 1% addition in the staff, there's a 0.6 percentage increase in the number of cases resolved by the courts. The same holds true for the pending cases, where if the pending cases increase by 1%, then the log of then the output also then the cases disposed of increases by 0.66. Now, so as I mentioned in the previous slides, that the number of observation in the current case is just 24. So to know whether there is whether the model allows for inefficiency or not, or whether inefficiency is still there in the model or not, one needs to uh, look at the bottom of the table. So it shows that that the likelihood ratio of sigma u is 0, and the value is 0.00, but the probability is 1.00. So in the current case, the null hypothesis is that the OLS only that the results only take care of the noise component and not the inefficiency component. So, and here we are rejecting the null hypothesis of inefficiency component being there in the model, and it might be on account of several factors like the number of observation being limited, and even the strong parametric assumption of half normal distribution. So before you are delving into SFA, one needs to you need to take care of the number of observation in the data set. So in the current case, we had 24 observation, which led us believe that there is no inefficiency. However, there might be inefficiency if the number of observations are increased beyond 24. Now, if you really want to know whether any variable is causing inefficiency or not, so you can also introduce a variable. For example. In the case of court, one factor that might be leading to inefficiency would be the number of trials in courts. So in that case, you comma here after here after writing this code, you will be using comma, t in the bracket, you will write the inefficiency causing variable, and then you would check the results whether the variable that you might have chosen for inefficiency is significant or not. So this is how we interpret the results of stochastic front analysis. Thereafter, we predict the technical efficiency score derived from derived from stochastic front analysis. So I'll be just using this command. So based on the the model has predicted the technical efficiency score based on SFA, and in the slides I have just shown the results of shown the results of technical efficiency scores derived from stochastic front analysis. So you might have observed that there were 24 high courts in the 24 high courts in India, and for each high court there is a technical efficiency score assigned. So based on that, you'll be comparing the high courts, you'll be comparing the decision making units and making further conclusions. So one, you might have noticed that there is no one that there is no decision making unit or the court in India which has attained the level of attained one as a technical efficiency score, which means that on average, Indian high courts are technically inefficient, and almost all the courts have an efficiency score below one, and which is how we can deduce that the courts are inefficient. Uh, so based on literature and even in your own understanding, you can also give the command of inefficiency causing variable in stata, and 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 the analysis would show you which variable is causing inefficiency, and how each and every variable is associated with the output variable. So for more analysis, you can also refer to the following material, and Stata provides Stata provides a lovely account of SFA, and along with other models that you can also estimate. Now let just let me know if you have any doubt, or you would like to know about SFA, or any other application.
Hello.
Yeah, hello.
Uh, 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 you wanted to say something. There is a question from Anna Mary Varghese. What is the
Mm-hmm.
scope of integrating DEA? I see it is in the chat box.
So there would be a methodological contribution if you would be using both these methodologies in the paper, and
Can you
there are.
kindly read, read that question also, know what she has.
Yeah, it's there in the chat box. Yeah. So she has written, what is the scope of integrating DA and SFA? Would data be an issue? So there are papers that have used observations below 30 also in a cross-sectional setup, and the papers are published, and they have used both DA and SFA. So from that angle, so since as I mentioned, that DA does not take care of random error component, which SFA has an advantage over. So if your main goal is if you want to say that you need not assume any production function for your case, then you can straight away go ahead with the DA. But if you want to show that your results are robust, then do apply DA and SFA alongside, and then you can compare whether both the efficiency scores received from both these methods are are aligning well with the literature or even your own understanding. So there won't be any issue if the results of SFA are in line with DA, then there won't be any issue. And then you can also comment due to some assumptions of SFA or even DA, the results are not aligning. So yeah, that could be the case. But yeah, SFA, what is the logic behind taking log form of variable? So it follows a Cobb-Douglas production function form, which is why SFA does require log form. And even the as I mentioned, that one needs to assume some distribution for error term like exponential, half normal, or truncated normal distribution. You need to take the log form of your variables. Yeah. So for methodological convenience and also the assumptions on production function that it is taking Cobb-Douglas form, which is why you need a log form to be there for the variables. Yeah.
Yeah.
Hello?
Yeah.
Fila, the thing is, like, in the case of DA, I remember that we eventually got some DA's like efficiency scores, right?
Right.
You showed the step by step method by which we
Hmm.
can get those scores.
Hmm.
Here,
Right.
you see, like, you got the parameters, right? The
Hmm.
corresponding parameters. But
Right.
then I'm just like curious. Can you just sort of break down the thing in a way so that I can understand, like, step by step, how are
Hmm.
you starting from that the production function that you are taking and reaching to this coefficients, and then how are you interpreting them answers?
Okay. So is that it, Abhi? Shivam, shall I?
Yes, yes,
Yeah,
yes.
yeah.
So, in data analysis, so in both these methods, you would indeed obtain technical efficiency score, right? But the approach is very different in both these cases. One assume a non-parametric approach, which is the DA thing, and the other is SFA, wherein you have a production function, which has a specific kind of form, wherein you have output variable, wherein there's input variable, there's an error component which subsumes both inefficiency term and the random error component, right? So in the table, in the when you perform SFA in Stata, in the first section you would just get the results of the output variable being regressed over the input variable, right? And thereafter you would get thereafter you would get sigma u, sigma v, and lambdas and all. If you have any other variable which is causing inefficiency, then that would also be taken care of in the second panel of the same frontier result. So what it does is that it'll perform it'll based on the inputs and the output, it'll get some technical efficiency scores, and the technical efficiency scores would then be interpreted in the same fashion, which is how DA is also interpreted. So if a technical efficiency score is below one, then you'd be calling it as inefficient. Otherwise technically inefficient. Otherwise technically inefficient. So if it is below one, it is technically inefficient. If it is one, then it is technically efficient. And again, like based on the rigidity of assumption that you are willing to take in your approach, you can decide whether you want DA or SFA. Yeah, this is it.
But, yeah, that's right. That's okay. That's okay. But then I again have this
Hmm.
that the parameters that you are getting are
Hmm.
in a way kind of you are getting through
Yeah.
regression thing, right?
Hmm.
So how is this particular approach, like the parameters that we are getting, are
Hmm.
different from the regression parameter?
So so in regression so you even if you perform the regression with just these outputs and the input, you won't get the inefficiency measurement, which would be on account of managerial skill or the even technological gap, which is taken care of taken care of in SFA. So why SFA is different from regression is the same thing that in the regression framework we just have one component of error, which is the random error component, whereas in the SFA there are two kinds of error. One is the random error component, the other one is the inefficiency causing inefficiency capturing error term. So this is how SFA is different from OLS. There are people that have also compared the results of OLS with the SFA results, and they're likely to be different. The magnitude are different. Magnitude is different of the coefficients. Um, However, the direction of causality remains a bit similar. So that's the case of regression with the regression being compared with SFA. But you won't get inefficiency when you are performing regression, and just like when even in
So
production.
it so in a way it's like analysis of error in the way, right? Like in the
Yeah, analysis of error more of, yeah.
yeah, right. So basically, in regressions, we assume that the error is randomly
Distributed.
like
Hmm.
distributed, right?
Hmm.
Normally distributed and random, right?
Hmm.
Here you are saying that there is one part of maybe a random, which is random part, and other is
Hmm.
associated with this inefficiency, and
Right.
that is giving us, in a way, that is analogous to the scores that we were getting in DA, is it?
Yeah. Yeah. Yeah.
So that is the basic difference, and so
Hmm. That's a basic difference.
yeah, in this way, the kind of regression parameters we are getting, do they become little more unbiased, or we can't comment anything on that?
Uh, I'm still unsure whether I would be able to comment on the same. I would have to look back to the literature for the same. But since MLE takes care of this efficiency assumption, one can say, yeah, it would be efficient because of the approach that SFA follows of MLE, rather than just performing OLS. So one can comment on efficiency, but I'm not sure that I'd be able to comment on biasness of the results. So yeah, I'll get back to you once I go to the literature on the same.
Yeah, that's it.
I think anybody else have any questions they can ask to Miss Sila Mishra. Any other audience, if you have any question. Okay, I think most of the people have asked the questions in the chat box. Uh,
Mm-hmm.
Now I would like to announce certain things for the upcoming programs, and then formally we will end the meeting also. So mostly by the next week we will have a debate. The tentative topic is we have got. It will be on digital economics and G20. How G20 is helping the digital economy to flourish in the world and helping the Indian economics. So if any of you are really interested to come as a speaker or one of the debater, so kindly you can directly text in the group. Flyer will be coming very soon, and after that, from next week, will be starting on the time series, followed by the panel data analysis. It will be on the platform of Stata mostly and on R. If any other people also, we will find to get in if somebody is very comfortable with the Python or any other statistical tools there, we can get this resource person, and then we will be coming with that. Otherwise, again, I would like to request all other member in the group, if you know somebody who can give lecture on certain topics of a time series or a panel data, so kindly let us know. It is all your group. Even everyone is the equally treated in this group. So even you people can take a lead and come forward with some of the topics or any other things if you want to do on any other topics. Kindly give suggestion to us, give advice us so that we can make it more better. uh, Still I have a request to the members that kindly attend the meeting. That will give an encouragement to do the program in the future also. So and that's all from us, and I'll be really thankful to Sila Mishra. Apart from her busy schedule and tight schedule, she has committed the 2 weeks with us. So behalf of research learning circle, we would like to propose put of thanks. Actually, formally, Shivam Chogole will be coming. Shivam Chogole.
Yeah, so um, Jawahar has he has actually mentioned everything that we have planned for the coming weeks. But then today's session again, as I see, was quite interesting in a way because those who attended the previous one could understand that it was based on the DEA. Here Sheila has quite nicely explained how SFA works and how it adds to the information that we are getting in terms of efficiency scores and all. So that especially I found it very interesting in the sense that how it also relates to the regression and is giving that the errors in the form of inefficiency, and those are becoming important tool for us to analysis. And I just especially like the fact that you have gone into so many details including the assumptions and the assumptions on the production function and its form, and then this normality assumptions and all those. So that was quite an interesting talk, especially because of the details and thoroughness you talked about, including the code that you have showed. So thank you very much, and I believe that both of these sessions on DE and SFA are useful enough for all of us. And I guess I hope that Sheila is always available for anyone to have any doubts in these regards, so that we can talk to her. Thank you very much for your important time and the efforts that you have put in, and that's all for the day.
Thank you, Shivam and Jawahar. It was so sweet, and be considerate and being observant too, with both the sessions. I'm more than glad to offer any kind of help to anyone if that's in my capacity. And do let me know if you feel stuck in both these methodologies. And since I've only talked about cross section, so yeah, like if you're willing to go ahead with panel, then do let me know. You can send me a personal text or even mail me if you're stuck with data, if you're stuck with the methodology in a panel setup, or even if you want some more papers that would help you in understanding both these methodologies in great detail. So yeah, thank you so much for being so patient with me. Yeah.
Thank you, Sila. And moreover, these recording sessions will be uploading on the YouTube. Hopefully, you know that the channel name, same channel name, it is there, Research Learning Circle. You can search on YouTube, and you will get the recording of this session, previous session also, and all other sessions. It will be available on that channel. So kindly go and see if you get help, or if you have any doubt, kindly come to us. We will assist directly to the speaker, or any other help we can do. We will propose the direct help also. The help is always welcome from our side, and only what we are expecting is only encouragement in the form of your presence in the meeting, and suggestions and the questions and queries